My name is Nam. I'm from Alterac Research Center from Germany. In this video, I will talk about two different methods for cross-device matching problems at CIKM Cup. The target of the competition is to identify the same users across multiple devices, or predict the new axis in the user ID graph using browsing log and metadata. So we will provide it for different files, URL, title, and trends. In the facts files, we have a set of the events for different users. Each fact is mapped into actual URLs and titles. In the training files, we have a set of pair of user IDs that refer to the same users. And our task now is to predict the matching pair for the users in the testing set. We first did some analysis and obtained some observations. We compute the distributions of number of pairs given by number of set facts between the user ID in the training file. And we did the same for the domains. We compute the distribution of number of pair given by the number of set domains between the user IDs in the training file. We observe that users tend to have the same facts or events, or they access to the same domains across multiple devices. That means two different user IDs that refer to the same users tend to share one or more facts or share one or more domains. So based on that observations, we generate our negative example and prediction set. So for each pairs in the training files, we generate 6 different negative pairs, and we end up with the 3 million training sample at the end. So for each users in the training set, we generate the pairs with other users that share one or more facts or share one or more domains, and we end up with 50 million pairs for our prediction set. We try two different methods for solving the problems. In the first one, we consider it as a binary classification problems. Given a pair of user IDs, we classify it into two groups, indicating that they associate with same users or different users. In the second one, we formulate it as the learning to rank problems. Given a user IDs, we rank other user IDs based on their probabilities of referring to the same users. So for binary classifications problems, we use a sample learning technique for solving that. We start with the different features we extract from the facts, from the domain, from the title, from the timestamp of the events, from the users. We also have some hybrid features that combine the fact with the times, domain with the times. And in total, we have the 75 different features. We use that as input for our first layer for the different classification algorithms, gradient boosting, random forest, or neural network. And in neural network, we have two hidden layers. We evaluate the individual classification algorithms, and we also use this as meta features for the next layer. So for the second method, we use the lambda ranks based on the 75 features previously. And the question now is how we generate the final prediction from the ranking score. First, we compute the distributions of number of connected components given number of nodes in the user ID graph, and we try to follow the same distributions for our predictions, and we try to generate the predictions that follow the same distributions as in the training file. And for doing that, we propose a greedy algorithm to make sure that we have the same distributions as we observe from the training file. So here's the results that we have. So we tune the parameters for the classification algorithms based on our own validation sets, and we see that the SM learning techniques outperform the individual algorithms, and we also test on the validations provided by the organizers, and we have the same behaviors. Thus, as ensemble learning techniques outperform the individual classifications algorithms. So we develop our learning to rank methods after the validation phase closed. So we cannot tune it on the validation datasets. So in the table 4, we have our final results, and the interesting thing here is the second methods, learning to rank methods, outperform the first one, classification methods. And the thing is, our final results, we tune the number of predictions, so that also have. So we have described our two different methods for solving the problems, the matching problems, and we learned that ensemble learning techniques obtain better results than individual algorithms, and the learning to rank methods outperform the classification methods. And the last one is tuning the number of predictions also help to boost our ranks and our score in the final test. So if you have any questions or want to discuss in details, just drop me an email and we can discuss. Thank you.